Okay, let's go ahead and get started. So I have all of the quizzes now and I have them graded. So let's go ahead and take a few minutes to go over the quiz. Okay, so number one, we were given -3 in parentheses squared. Yes, sir.
Is this the one that I didn't get?
Quiz 3?
Yeah.
I thought I sent that to you.
Yeah, but the one you sent me, it said answer key on it.
Like I think I said to you in that email response that the answer key up at the top doesn't actually say the answers on it.
Oh, okay.
So unless you actually see answers down at the bottom of that quiz, then it's the correct one.
Okay, well, that's why I didn't do it, 'cause I thought it said answer key, and I don't know the right one.
I can send you another one real quick,
Okay, can you do that, please?
just to make sure. What's your last name?
Luevano,
Spell that?
Luevano.
Gotcha. Let me just check and make sure this is correct. Yeah, that's correct. Okay. So I just sent it to you. And so if you'd like, you can go take that right now. Since we're going over the quiz right now. Yeah, you should be able to get the library. Okay. So again, number one, we're given -3 in parentheses squared. So the important thing here is those parentheses, because the parentheses around that -3 mean that we're including the negative along with the 3 when we square. So this would literally be -3 times -3, and a negative times a negative is a positive. So this will be positive. 3 times 3 is 9. So there's our answer. Any questions? Okay. Next one, pretty similar. This is -2 to the 6th. However, we do not have parentheses around this number, which means that we are not including that negative when we take the power 6. So this is like having negative, and then 2 times 2 times 2 times 2 times 2 times 2. Does that make sense? Okay. So we're not including that negative in the power. We're just doing this. So let's see, 2 times 2, 2 times 2, 2 times 2. Each of these is 4. 4 times 4 is 16. And then times another 4. That should give us, let's see, 64? Oops. 4 times 16 is 64, yeah. So this part gives us 64, but we have to remember that this negative is still on the outside there. So it drops down and we have -64. So the answer we're looking for is -64. Any questions? Nope, makes sense. Okay. Next one, simplify the following expression. So we were given 2 to the 4th times 2. Okay? So you could do 2 to the 4th and then multiply it by another 2, but remember that this is kind of like having a power 1 on this 2. And so when we multiply things that have exponents on them, we add those exponents. So this comes out to be 2 to the 5th. And now we can multiply 2 times 2 times 2 times 2 times 2, or 2 to the 5th. And so 2 to the 5th gives us 32. Any questions? All right. Next, simplify the following expression, writing your answer with only positive exponents. So what it gives us is z to the 4th times z to the 5th all over z to the 6th. Okay? So we've got some multiplication and division going on here with our exponents. And we want to make sure we get the top and the bottom as simplified as possible before we start dividing anything. So let's go ahead and multiply z to the 4th and z to the 5th. So again, when we multiply things with exponents, we add those exponents together. So that will give us z to the 9th on top. And now we can go ahead and divide that, and z to the 9th divided by z to the 6th, since we're dividing, we will subtract those exponents, and that gives us z to the 3rd. Any questions? Okay. Next one, simplify the following expression, writing your answer with only positive exponents. So same deal. We've got negative 4a to the 3rd. Sorry. Negative 4 over b to the negative 2 power, all raised to the 3rd power. So following our order of operations, we should do anything in the parentheses if we can, and we actually can. B to the negative 2 power, that negative power on b is going to cause it to flip up to the top. So this will now be negative 4a d to the positive 2nd now, all raised to the 3rd power. Okay? So next, we need to raise everything to the 3rd power. So negative 4 raised to the 3rd. This is in parentheses, so we're including that negative. But it's a negative times a negative times a negative, which will give us a negative anyway. So this gives us, let's see, negative 4 to the 3rd power is negative 64. A to the 1st raised to the 3rd. When we raise something to a new power, we multiply its current power by the new one. So 1 times 3 is a to the 3rd. Then b to the 2nd raised to the 3rd. Again, we take the original power and multiply it by the new one. And so that gives us b to the 6th. Any questions? Nope. All right. Next, we're given a radical, and it wants us to simplify the following radical expression. So 15, or I should say square root of 15 x y to the 10th. Okay, so let's start with that 15, see if we can break it down any. We want pairs of factors that will match. So that's 5 and 3, and no, I don't see anything that matches there. So it's going to have to stay 15 and stay under that root. Next, x. Can we break anything out of it? No, it's just x to the power 1. So we can't make any matches. We can't break any factors out of it. So it's going to have to stay x to the power 1 underneath that root. Then we have y to the 10th. First we check and see, Is this divisible by the type of root? 10 divided by 2? Yeah, we can do that. That gives us y to the 5th on the outside. And so there's our answer we're looking for, y to the 5th square roots of 15x. Okay. Next one, we have y over the square root of 2x. So the problem with this one is that it's not got a rational denominator. And what it says is simplify the following radical expression by rationalizing the denominator. So we want to get rid of this root here. And if we want to get rid of root, the best way to do that is to square. And remember that squaring means multiplying it by itself. So we'll multiply the bottom by square root of 2x. But of course, whatever we multiply the bottom by, we have to do the same thing to the top. So we're also going to multiply y by square root of 2x. So the bottom here, square root of 2x times square root of 2x just gives us 2x. Then y times the square root of 2x is y square roots of 2x. And there's our answer. By the way, I did have some people who didn't know how to make powers and roots and things, and so they had to like write out the answer like as a sentence. So like y to the power of 5 square root of 15, or y square root of 2x over 2x. And if you did that, that's fine. I counted it correct. Okay. Next. Says find the product of the binomial factors using the appropriate special product. Really complicated way of saying we have x plus 2 and we want to square that. Okay? So if we want to square this, again, we need to remember that squaring means we're multiplying this thing by itself. So this is x plus 2 times x plus 2. And then we'll go ahead and multiply that. So x times x, we get x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Now we need to simplify it if we can, which we can. We can combine these two like terms right here, and we get x squared plus 4x plus 4. And there's our answer. Any questions? Okay. Next one says factor the following trinomial. And if it can't be factored, say not factorable. So the trinomial it gives us is x squared plus 3x minus 10. I didn't want to give us one that couldn't be factored, so this one absolutely can be factored. And since it's a trinomial, we need to start off by doing the AC method. Remember that the A is the number in front of x, and C is the last number, negative 10. So the number in front of x is 1. Multiply that by negative 10, we get negative 10. Now we need to find factor pairs of negative 10 that will combine to get positive 3. So negative 1 and positive 10, negative 2 and 5. That's all I can think of besides the opposites, which would be positive 1 and negative 10, and positive 2 and negative 5. So it looks like 2 and 5, negative 2 and positive 5 will give us the positive 3 we're looking for, so we'll replace it with negative 2 and 5. So we have x squared minus 2x plus 5x minus 10. And at this point we could either do factor by grouping or the box method. And I'm going to do the box method because that's the one I think is fastest. So draw out my box and split it into 4 pieces. First term, x squared, goes in the first box. Last term, negative 10, goes in the last box. Then it doesn't matter where I put the other two, I'm going to just stick 2x in here, and its sign has to go to the top if I put it there. And 5x is going to go there, and its sign has to go out to the side. So now, I factor my rows and my columns. So this will be x, this one has 5, this one has x in common, this one has 2 in common. So my factored form is x minus 2, one across the top, and x plus 5, the one down the side. So there's our answer, x minus 2 times x plus 5. Any questions? All right. Next one. Number 10. Again, we want to factor, and it gives us x squared minus 9. Well, it's not a trinomial, so we can't use AC method. And I don't see anything common between x and 9, so we can't just factor a GCF out. So it's got to be something else, which, yeah, we have one more technique, and that is the difference of squares. X squared is a square, 9 squared is a square, 9 is a square of 3, and there's a difference, so this is a difference of squares. So we know it factors into 2 parts. They should be conjugate binomials, so one will have plus, one will have minus, and then we just take the square root of each of these numbers and fill them into the places. So square root of x squared is just x, and then square root of 9 is 3. So our 2 factors are x plus 3 and x minus 9. Or x minus 3, sorry. Don't know what's wrong with me today. I've been stumbling all over my words all day. Okay, any questions? All right, last one was a bonus question. And again, like I had told us, the bonus would be worth 10 points because I figured it would be quite difficult. But I did show you how to do it. Okay? And I'm pretty surprised. A lot of people tried it and got it right. So here's what I gave you. 32 y to the 4th minus 2 v to the 4th y to the 4th. So we need to use our factoring skills to try and factor this polynomial. Well, the first thing we should always check for is, do these two values have a common factor? Can they both be divided by something? And yes, they can. They can both be divided by 2. Also, they can both be divided by y to the 4th. So we can take 2 y to the 4th out of both of these. Okay? So when we take that out, 32 divided by 2 leaves us with 16. Y to the 4th divided by y to the 4th cancels. 2 divided by 2 cancels. V to the 4th doesn't have anything to divide by, so it stays there. Y to the 4th divided by y to the 4th also cancels. But we are not done yet, because this can actually be factored farther. Sure, we took the 2y to the 4th out, but 16 minus v to the 4th is a difference of squares. 16 is a square of 4. V v to the fourth is a square of v to the second. So we can break this up again as 4 plus v to the second times 4 minus v to the second. Again, it's a difference of squares, so it comes out to be a conjugate binomial. But even still, it can be factored. There's another place that we can take things out, and that is here. 4 minus v to the second. 4 is a square of 2, v to the second is a square of v. And it's a difference, so we can factor it. This one cannot because it is not a difference of squares. It's not a subtraction between them. So we have 2y to the fourth times 4 plus v to the second times 2 minus v times 2 plus v. And it doesn't matter what order these are in, just as long as you have all 4 of these factors. So again, I figured that this one was worth 10 points because there was so much factoring in there, and you had to check and make sure that you were actually done before you stopped the question. So if you got it, you got 10 points, 10 plus points. And again, I'm quite surprised. There were a lot of us who attempted it and got it correct. So I'm pretty happy to see that. Any questions? All right. So that's the quiz. Now, I believe Mr. Brzezinski has started in on imaginary numbers and complex numbers, correct? Things with I, right? All right. So, let's go ahead and take a look at these numbers. So first of all, beginning of the semester, we were talking about different types of numbers. And we said there were real numbers, there's integers, rational numbers, irrational numbers, natural numbers, all these kind of things. But at the beginning, I said that there were 2 basic types. There's real numbers and non-real numbers, or imaginary numbers. So where do these come from? Think about this. Square root of 4. And I've mentioned this before. Square root of 4 is not just 2. What is the other answer we have to take into account here? -2. Very good. So the square root of 4 is not just 2, it's 2 or -2. It has 2 answers. So if we think about the square root of -4, what would be the answer there? What was that? Very close. So the question we're asking with the square root is, what times itself equals this number? So 2 times 2 equals 4, but that's a positive 4. It's not negative. And -2 times -2 also equals positive 4, because a negative times a negative is a positive. So what would we multiply together to get -4? The answer is, don't really know. But remember that one of our properties of radicals says that we can split this up into 2 parts. We can split this up into the square root of 4 and the square root of -1. So square root of 4 times square root of -1 will get us that square root of -4. Well, we know this part, don't we? We know that it's 2, probably. Might be -2 as well, but for right now we're just going to say 2. It's this part we're having trouble with. We don't know what the square root of a negative number is, because if you square a number, it will never be negative. And here's where imaginary numbers come in. For a very long time in mathematics, mathematicians saw this and basically said, well, it doesn't work. It just breaks. There's no answer here. We can't go any further than this. And relatively recently in mathematics, within the past 200 years, some mathematicians have said, well, what if we just treat this as a number we don't know, like we usually do in algebra, and say it's like a variable? If we don't know what a number is, then we call it a variable, don't we? Like x. X represents numbers we don't know. So we'll call it I. Or this imaginary number, this number that we have to kind of use our imagination with. So the answer for square root of negative 4 is 2i. Okay? So these numbers over here, these are real numbers. They exist on the real number line. 2i, things that have I in them, are called complex numbers or imaginary numbers, but I like to call them complex. And they exist on the complex number line. It's like having a second number line out there. So we're used to a number line that looks like this. So like 0 in the middle, and then maybe 1, 2, 3, 4, 5, and then on the other side we have -1, -2, -3, -4. So this number line right here includes all of the numbers that we can possibly come up with, including things in between them, like in between 1 and 2 is 1.5. And then in between 1 and 1.5 is 1.25. Okay? So all of the numbers that we can possibly imagine are on this number line. This is the real number line. Okay? So we have to start thinking about a new number line. And it's a line that kind of intersects this one. On this number line, we have very similar looking numbers. We have -1, I, -2, I, -3, I, -4, I, -5, I, and so on and so forth. We also have 1i, 2i, 3i, and they intersect at this point right here, 0. 0i, well, 0 times anything is 0. So that's the same thing as having a real number 0. So they do cross over at this one point right here. But other than that, they do not cross. And our real number line combined with our imaginary number line makes what's called the complex number plane. So for instance, if I were to pick a point like right here, it's not on one of our number lines, it's somewhere out in this empty space. This is a combination of 2 and -3i. So it would be 2 minus 3i. So far in our math careers, we have seen just numbers on a line. That's it. Now that we're getting into imaginary numbers, we can see that numbers don't just exist on a line, they also exist in a plane, in space. So these are called complex numbers. Complex numbers are made up of a real number and an imaginary number. And they're these numbers that exist off of the lines that are in this empty space out here. Does this make sense? Any questions? Okay. So we have a new type of number we need to take a look at. So, just like any other number that we are introduced with, we start trying to do operations with it. So let's try add. So something like 3 plus 4i. And then we want to add to it 2 minus 7i. Chances are you already know how to do this. Remember that what I said is it works like a variable. It works like x. So imagine this was 3 plus 4x and 2 minus 7x. If we wanted to combine these, or add, we would just combine like terms, wouldn't we? So that's exactly what we're going to do. So we have like terms 3 and 2. Those are our real number parts. So 3 plus 2 is 5. And then we have our non-real number parts, or imaginary parts, 4i and negative 7i. And so if we combine those, we get negative 3i. There's our answer. Again, that I works exactly like if it was an x, if it was a variable. It's just that in this case, we know what I is. It's the square root of negative 1, which I'll be repeating quite a few times through this lecture. Any questions? Okay. Let's try another one. 5 minus 3i minus 2 minus I. Well, again, it's just like if that I was an x. We just combine like terms. But, careful, what should we really do before we start combining anything here? You got it? Yeah. Yes. This negative, if we see a negative on the outside of parentheses, we should distribute it. So change this into a plus instead. Now we have 5 minus 3i plus, see, negative times 2 is negative 2. Negative times negative I is positive I. Always make sure that if you have a negative on the outside of your parentheses like that, you distribute that negative. And so now we can combine like terms. 5 plus negative 2 will give us 3. Negative 3i plus I will give us negative 2i. Again, that I works exactly like if it were an x, if it were a variable. It's just that we know that I is the square root of negative 1, but we don't know what the square root of negative 1 really is. Any questions? Okay. So if we can add and subtract, we can definitely multiply this thing. let's try 2 plus 3i times 3 minus 5i. Well, pretty much like what we did on our quiz. If we have x's and binomials, which this is basically a binomial, we just multiply it by distributing. So 2 times 3 gives us 6. Then 2 times negative 5i gives us negative 10i. Three I times 3 is 9i. And then 3i times negative 5 gives us negative 15i squared. And that's really important. Don't forget that square on that I. If we multiply 3i times negative 5i, both of them have i's. Just like if this was 3x and negative 5x, we'd have x squared, right? So this needs to come out to I squared. And there's a very important reason for that. First, we have like terms, negative 10i and positive 9i, right? So if we combine them, we get negative 1i. Now let's take another look at this I squared. Again, I is like an x, it's like a variable, but we know that it equals the square root of negative 1. Let's think about that real quick. If we have instead I squared, then that's the square root of negative 1 squared. Well, what do a square root and a square do to each other? Why? What do the square root and the square do to each other? They cancel, yes. So if we have I squared, that means we have the square root of negative 1 squared. These two things cancel, and it gives us negative 1. So minus I minus 15 times negative 1. So really this is negative 15 times negative 1. What's negative 15 times negative 1? What? Yeah. Negative 15 times negative 1 is positive 15. Well, does that mean that we have more like terms now? Yeah, we do. So 6 plus 15 is going to give us what? $21, good. So we have 21 minus I. And for the most part, that's what you can expect to see when you multiply these complex numbers together. Remember how when we multiply binomials together, we're used to seeing a trinomial come out? Complex numbers are basically one value shorter. You multiply two of them together, you get two numbers out, two values. Except for one case, and it's the same case that we had for polynomials, for the numbers that we were multiplying before. So when we multiplied conjugates before, instead of getting three numbers out, we only got two. So let's see what happens when we multiply conjugate complex numbers, or complex conjugates. So remember that a conjugate is a number that is the same as another one. It's just the sign in the middle has changed. So 2 plus 3i and 2 minus 3i. Complex conjugates. Okay? So now, let's multiply these. 2 times 2 is 4. 2 times negative 3i is negative 6i. Positive 3i times 2 is positive 6i. 3i times negative 3i is negative 9i squared. So now let's combine like terms. Well, that's negative 6i and positive 6i. Those cancel, leave us with just 4 minus 9i squared. But we know that the 9i squared is really negative 1. So what is negative 9i squared going to change into? Just positive 9. So now we have 4 plus 9. 13. So that's something really interesting there. Complex conjugates, when we multiply them together, give us a real number. Any questions? None? Okay. One more thing. So like we saw when we multiplied these things together, I squared can come out to be something kind of interesting. Again, we say that I, or in other words, I to the first, is the square root of negative 1. And then we saw that I squared, because that square cancels out that square root, comes out to be negative 1. Okay? So what about higher powers? I to the third, maybe. Well, I to the third is like a combination of I to the first and I to the second. It's negative square root of negative 1. How about I to the fourth? It's I squared and I squared, so it's negative 1 times negative 1, or 1. Okay? So now, what about I to the fifth? Will it be this one, I to the fourth, and this one, so 1 times square root of negative 1 is just square root of negative 1 again. And in fact, if we keep going with higher and higher powers, it just repeats this pattern. Now let me clean this up a little bit for y'all. I to the first is I. I to the second is negative 1. I to the third is negative I. And I to the fourth is 1. And it will repeat this pattern. So I to the fifth is I to the sixth is negative 1, I to the seventh is negative I to the eighth is 1. If we go opposite direction, I to the 0 is 1. Anything to the 0 power is 1, right? I to the negative 1 would be negative I to the negative second would be negative 1. I to the negative third would be I. It repeats this pattern no matter which way you go. So, I raised to a power can only be one of these 4 things. So knowing this, what is I to the 235th power? Well, you could count that far. You know, I, negative 1, negative I, 1, I, negative 1, negative I, 1, I, negative 1, negative I, 1, keep going like that, but you'd be there for hours. There's a much easier way to do it. So it can only be one of four things, and it's always in the same pattern, which means that this pattern follows four steps. So what we can do is we can take 235 and divide it by 4, and that will give us a place in our pattern that we land on. So 234 divided by 4 gives us 58.5. Now the 58 doesn't matter, I don't care about that. It's the 0.5 that actually matters. And here's why. If you divide a number by 4, it will come out to be one of four things. Either 0.25, 0.50, 0.75, or 0.00. And it lines up with the steps here. So 1 divided by 4 is 0.25. 2 divided by 4 is 0.5. 3 divided by 4 is 0.75. 4 divided by 4, we get 0.00, or 1.00, really. But because we've divided 235 by 4 and got a 0.5, that means that it's on our second step. That means that I to the 235 equals -1. How about I to the 6,478th power? Well, again, just do 6,478 divided by 4. That lands on 0.5, so this one is again -1. It doesn't matter what number you have in that power. I to the negative, I don't know, 5th power. -5 divided by 4, 0.25. So this is I. Any questions? Okay. So again, treat I as if it's just X. Because that's essentially what we're doing here. We're replacing this number with a variable, I. It's just in this case we know that I is the square root of -1. The problem is that we don't know what square root of -1 actually is. So we're replacing it with I to try to work through things. Again, pretty recently in mathematicians looked at this and wouldn't have been able to do this at all. They would have stopped here and said, I don't know. But now that we know that we can replace that with I, we can keep going a little bit further and even find some real numbers that we can work with. So I think that'll do it for today. I hope y'all have a good day. I will see y'all on Friday.